Hi, I'm just going to show you how to use Microcap12 to simulate a simple electronic circuit. You see here in front of us a voltage divider bias for NPN transistor. We got two resistors on the voltage divider, R1 and R2, and we have RC, RE, and the voltage of bias, which is equal to 10 volts. To do that, you open your Microcap, and I already opened a file here, but I'll show you how you open a file in general. When you do that, you can just go to New, and then you will see a dialog box showing you schematic file.cir. That's what I'm going to choose, and you will just hit OK, all right? So let's go back to the one that we are going to use. You open the file and then you save it by the name whatever you know. So I save it as, and I save this one. I call it lab1 250. All right. So you save the file. All right. And now we'll start. We'll start picking components. We'll start with the resistors. So you go component and analog primitive. You move to the passive component, and then you'll find the list. You choose resistor, you click on the resistor, you get here, you click back again. It will open a dialog box, and you go there for the value and put the value of the resistance that you want. In this, I meant to have R1 equal 10 kilo ohms, so you just type 10K without typing ohm, and then you hit OK. Then you got the resistance R1 equal 10 kilo ohm. By the way, you'll find just since you are in the mood of picking resistor, you'll find another resistor coming in your hand. That's okay. Just go ahead and finish it. Align with it. Click. Then you need to insert the value of R2, which is 3.3. So just type 3.3K and hit enter or OK. Both are the same. You got another resistance. That will be RC. The value is 5.6. So you say 5.6K. Course, and then you hit OK. You got it. Another one that will be RE, which is equal to 4.7. That will be 4.7K, and OK. You got. Well, then you'll see you still have resistance, hanging there in the tail of the mouse. Just you want to get rid of it. Just you'll go there on this arrow, which is select mode, and click just to be free and move around without being bothered by this. So what else you need? You need the voltage, 10 volt DC. So you go to component and analog primitives. You don't go for the passive or active. You go for waveform source, and then you will see in the list the first one in the top, battery. By the way, if you look at the bottom, the left corner, you'll see there's a voltage in here. Just I have to go back again and show you that's the battery. Then you find the square to the left corner on the bottom of the screen showing the voltage to make sure that you are choosing the right component. Then you click on the battery, then you get it here, maybe put it there, that's okay, and then click again, you get the value. You need 10 voltage. You write, just type 10, don't write voltage, just you understand that's a voltage. You write okay, you got 10 voltage. Still hanging there. No, you go select mode just to get rid of it. What else you need? You need transistor. All right, transistor is an active component, so you go for component, and you go for if you go analog primitives and you go to the active devices, then you can choose NPN transistor, but it will not give you the type of transistor, and that's okay. If you don't care about the number of the transistor you're going to use, you can use this one. But we already know the type of the transistor that we need. It's 2N3904. So just go ahead to the library, analog library, and you go for BJT. That means bipolar junction transistor. And you go there are type. We know we're in Darlington. We need general transistor. That's you choose general. And then you start with 2 because you have 2N. It gives you here options. So you just move till you get 2N. Remember the transistor here that you have is 2N3904. So you try to find 2N33. All right. So, you go here. I'm sorry. 2N3903. That's okay. Then you give you the whole family. So you can vote 3 or 4. Doesn't matter. So let's just make 4. as we picked, and then the transistor you put it there, all right. And what you will do, you go to select mode, and what else left? Oh yeah, there is something important, the ground. Any simulation package will not work without ground, so we want to get ground, so we'll go to the component, analog primitives, and you go there to connectors, and in connectors list you'll find ground, so hit ground, put the ground there. Now you go to select mode, be free. Now you want to arrange these components in a way you can connect in easy way. So I'm just going to move this one a little bit in the top here, in the bottom we have space, and we have another resistor here, all right. So, and you align them. Okay, I just like to say something here. I know that we don't need to rotate any components because they are just exactly the same way it looks in this circuit. But in a way, let's just say that you want to make this horizontal. So what you're supposed to do, you should make sure that you are in select mode, or select mode, and then you click, and it comes green, and then you go by the right button on the mouse, and then you click, then you get the list, you go to rotate. It gives you the option. You choose whatever position that you need, horizontal, vertical, whatever. In this case, I don't need, just to go back again. What else I'm going to say? Let's now name the components as they appear in the circuit. R1 and R2, this is R1, R2, that's good. This is RC, this is R3. So what should I do? Just make it green here by clicking, and then double click on R3. Then you will have their box. Just you can erase it and write whatever you do. I typed RC. This one I need to change, double click, remove it, type RE, great. This transistor Q1 is okay. This voltage, we call it VCC, double click, oh, I'm sorry, see, when you click just like that, let me show you. It will get you how you change the things, but no, you just go there, make it green, that you want to change, click, and then double click, and then write VCC. All right, so now we have everything is fine. Now you want to connect them. So you got to go to the wire mode. This icon, wire mode. Then click. And then you'll find, you see how it looks like. You have this wire mode hanging with the arrow of the mouse. So you want to connect this to this element. All right. So, but I observe they are not on the same line. So I go back again to this mode and just click, and then by the arrow move it a little bit to the right. All right, that's a line. All right, let's go back to the wire mode, and then you click here and keep pressing the mouse, and then drag till you go to other points, connect it. And let's just connect this one here, drag it till you connect it here. That's right. Connect, click, and drag the mouse till you connect this element. Click, drag, connect it, click, drag to connect the voltage divider. And then you drag and you connect here. Now you need to connect the voltage. So click, oops, I'm sorry, because I didn't click at the end of the, I have to go to the end and click and drag, connect here, click, drag. Then the last element is the ground. All right, so everything, don't forget to go to the select mode, because you'll be annoyed if you kept it on the wire mode. Now you have the circuit already built. Easy, simple, didn't take time. The second step, just you ask yourself, where are the nodes that you want to measure the voltage? So you want to measure the voltage at the collector. So just you go there, you are in select mode, and then you put the mouse there, and then double click. All right. This node is already named by 3, but you want to make something that you understand. So uppercase C, and say OK. So this node now is defined by C. And this one, double click the left mouse, and then you write E, that's the emitter. Uppercase E, OK. And this node, which is 2, but you double click by the left and write B. So I think these are the important nodes that you like to find the voltage at. So you are ready. These steps are easy, simple. To analyze the circuit, you just go for analysis and then click. And then the first one in the top, you choose transient. Then when you do that, you will get this dialog box. All right. This one originally was like 1 micro when you see it more, but I just changed it to a milli. It doesn't matter right now. You know, what does it mean, the maximum runtime? It means that the x-axis will be the time, and we'll start from 0 up to 1 micro. So the total time of the simulation will be micro. You can change it as you like. And the second important here, that originally if you open it, because I changed it, that was 51, the default value. You can change it to how many points. It depends on how smooth you want to see your curve, or the curve of the result or the oscilloscope. These things is like not important right now because we are solving DC, so we don't care. But what I care about these things here, right? The voltage that you want to see and the page. Let me just erase everything here. All right, if you just delete everything and see what's supposed to write in everyone here. This expression should be all in T. T means time. Now you are going to change. You have collector, so you write VC, all right? That means it's going to find the voltage at C. You want to find, you go by the mouse and then go there and type E and erase this B. So all right, now we are going to calculate this one, and which one, the base we define by capital B or uppercase B. All right, you don't have the things, you just erase it, just delete it, and then you are interested in the three things. All right, let's say the X range auto. All right, auto, and see what you're going to get. So remember, in this Y expression, you will find already something typed here automatically by the default. You can change it if you didn't find it. If you find the voltage that you need, or you don't have to change. What about this page? Or the first one, make it 1. The second one, make it 2, and then make 3. So you'll find it in 3 different graphs on the same page. All right. So what's next? You go and say run. Here you go. Then you see the result here happening, the values. Well, you don't have now to pay attention to what the graph look like, but just I'm going to show you if you want to change the range of Y or X axis. You just go there and just double click by the left mouse, and then you will get the dialog box that will tell you which one you want to change. For example, this is VB in the end, so you go for VB, you just mark it, comes blue, and then if you go to scale and format, then you got X-axis and Y-axis, you can change everything. For example, I mean, this is one from 2.47 to 2.47, just smaller change. Well, you say, okay, I want a Y-axis run from 0 to the high value will be 3, so you can get straight line. And the grid spacing, you can choose, for example, grid spacing. All right, you have from 0 voltage to 3 volts, you want to have like 0, 1, 2, 3, so 1. The spacing will be 1. All right, what else? I think that's all. So let's just say apply and see what's happening. Apply, okay. You see, and then you get smooth straight line here, this one. Well, maybe also that you need to make some change in this line in like the width. Go for the color fonts lines, and you go for the width. Instead of 1, you just make it 3, see what's happening. And you can change the color if you like, but it's okay. It's okay. So it's like apply, okay. Here you go, you see, that's nice. So you got this green line, thick, obviously, and you got the grid. So that's the way how you see it. You can change the rest of it, but I don't want to waste your time for that. Interesting. So let's say that you don't want to look at these graphs and want to look at the values as a text. You go for transient and you go down to numeric output and just click by the left now, and then you go. You got the report here. So what you got here, you got all information needed for simulation. I'm going for to look for the things I'm interested in. That's DC operating point voltage. This is the node, this is the voltage. So node 1, but you know, I don't remember what 1, but I remember E. So look for E. Node E, the voltage is 1.833. Remember, write it down. So VE is equal 1.833. Node B, it's equal 2.474 volts, of course. Node C, it's 7.832. Here you go. That's the result as a voltage. Okay. Of course, if you go down to the text, it will tell you many things about the beta value, the beta DC is equal, the beta AC, all the things. You can get all the information. Of course, there is extra information you don't need right now, but you pick the thing you are interested in. Like what? Like this current terms. The current terms, you have IB and IC. This is the current through the base, is 2.88 microamp, and IC, the current 387.06 microamp. So you have the base current, you have the collect current. You will get all the things. Even you see, even the resistance here, you see RO, this is the output resistance of the transistor, that's 276 kilo ohm. If you want the voltage between the collector and the emitter, interesting, that's what interesting. Voltage, it's 6 voltage, all right? So you can get the whole information in just the AC and DC, everything, all right? So that's very helpful one. Well, let me show you something else you will be interested in. Look at the bottom here. That's the analysis that you can look at this one. This is your original circuit .cir. Remember that. Click by the left mouse. Now you get back to thing. Let's now say that you want to find the voltage, the current. Typed here. Excellent. We'll just go there in the top, this icon. It looks like a voltmeter here. And then when you hover the mouse over node voltage, let's see what's happening. Click by the left mouse. All right. So this is the voltage at the base, 2.474. That's the voltage at the collector, 7.832, and the voltage at the emitter, 1.833. If the grid bother you to read the result, so you just can go to option and you go for view and you just move to no grid. Okay, you gotta just clean here so you can see the voltage. That's 10 voltage. That makes sense because this is a battery, 10 voltage that's connected here. There is no voltage drop, so 10 voltage, all right. But it doesn't show you the voltage between the collector and the emitter. But it's easy. You can subtract VC minus VE, you get VCE. All right? Well, maybe somebody say, okay, I want to know the current. All right. Remember, this is the icon for the voltage. You go next. That's the current. Click by the left mouse. Ooh, you got the blue here showing you in a rectangle shape here. So I'm interested in the current in the base. That's the current in the base. And when you hover the mouse, by the way, you get more information here. Okay, I don't want to bother you by this information, but just this is the current in the base. 2.889 microamp. Excuse me. And that's the current in the collector, 387 microamp. And that's the current in the emitter, 389.9. Observe that the current in the emitter almost the same. And that's what we explained in the lecture, that we can consider IE is equal IC. They are so close. That's the difference, only in one digit here in the top, especially in micro. So that's the information. Let's say, okay, I want also to know the power. You can go to the third icon, power. Click. You'll get the power in red, actually. So you got 3 different colors, okay? So in this little square, it shows the voltage at each node. And the blue one show the current in this resistor, and this is the power. And if you move the mouse, hover the mouse just over anywhere here, it can give you information, you know, about the voltage, about the current, about everything that you need. All right. So that's how you do the simulation by using Microcap12. Is really easy and simple. All right. And of course, if you want to make a copy or something, you go for edit, and then you just here copy to the clipboard. You choose whatever, clip the visible portion of window, or copy the entire circuit page in whatever you know you want to see. So just I'll choose copy the entire circuit page in this BM format. Let me check if I open a new file here. That's your experiment, but I new. and see, what is that? I want a new one, new page, new page. All right, let me see if I paste here, what will happen? Paste. Oh, I got everything in the screen. All right, you don't have to make a screenshot. So that's good. Well, let's go back to Microcap. Well, I'd like now to show you what you're going to do in the lab. So to show you that, I'm going to use different program because it will show the physical shape of the DMM, digital multimeter, and everything. So just let's close this one and go to Multisim. I have already Multisim open, and just, you don't, of course, don't have Multisim. Why I'm doing that right now? So I will show you how you measure the current and the voltage in the lab, because it will show you physically the instrument and the device you're going to use. Well, anyway, that's also be a good chance to whoever who has Multisim or using Multisim online. So I'll go for the component here to make it. I think I have one ready. So just to save your time, let me look if I have one ready here open. Let's see if this is the one. I have many files here. See, busy. Let's go for lab. Okay, save your time. I'm going to close everything, and I will just show you how you connect the digital multimeter to measure voltage and current. So it's important to know that. All right, let me connect everything. That's what you're going to connect in the lab. Let's just make this one look nice. All right. That's what you're going to see in the lab. All right, let's make it bigger here. Well, this is the voltage divider, or C or E. All right, I can change, but you understand what I'm saying. Let's now, if you want to measure voltage at any node, it's really easy. What you want to measure, I want to measure the voltage between the collector and the emitter. All right, so let's move this one a little bit here. That's the collector, that's the emitter. So in the lab, you are going to get your voltmeter, and the positive terminal of the DMM you connect to the collector, and the negative you connect to the emitter, and then you adjust the scale to the voltage in DC, right? And then you switch on your circuit. Then you will get the voltage between the collector and emitter, which is equal 5.99, which is 6 volt. It's exactly what to get to Microcap. But this is how you connect. I don't care about the result, about the connection itself. Well, remember, you have only one voltmeter in the lab, so you got to use it like every time you want to measure something, you disconnect and you connect to measure. So that's the way how we measure VCE. All right. What else you want to measure? You want to measure the voltage at the base. So how you measure the voltage at the base? You get the voltmeter close to the circuit, and the positive you connect it to the base. That's the base. And the negative you connect it to the ground of the circuit. Adjust it to the voltage DC, and then you switch on your circuit. It will measure the voltage at the base, which will be 2.473, right? All right, so it will measure the voltage at the base. What else? Okay, so VCE, VB, you can measure any voltage by connecting the positive and the negative terminals of the digital multimeter to the point you want to measure its voltage. The problem is when you want to measure the current. So let's say now you want to measure the current in the collector. To do that, to measure the current, you got to disconnect the collector, to disconnect the resistor RC from the transistor. Remove the connection. That's step one. Step two, you connect the positive to this terminal and the negative to the collector of the transistor. Why? Because when you measure the current and you want to get a positive value, you got to follow the direction of the current. So the current will coming from the voltage, 10 voltage here will moving like that, moving in the resistor and entering the positive terminal of the DMM. That's why we connect the positive to this terminal of R. Why? Because the current always should enter the positive terminal of the ammeter or the DMM when you measure amp. And then the negative current will go inside the coil here, coming out, going there, completing the circuit. That's important. All right. Then you, and the other thing, adjust it on measuring the amp, DC, because there are many mistakes happen in the lab. Usually the student forget to connect to the digital multimeter in the amp because you have different terminal. There is the one to the right, I remember, for the voltage, and the one in the middle for common, that's the ground. The one to the left is the amp. So you got to make sure about that and adjust the scale of the meter, and then turn on your circuit to measure the collector current. So it will give you the collector current is 388 microamp. It's a small current. It means when you are in the lab, you got to adjust the scale of the amp to the lowest one, so you can measure the value. All right, adjust the scale. Okay, we measure the current in the collector. What else you need to measure the current in the base? So how you do that? You disconnect your DMM, because remember, you have only one DMM in the lab. And then you want to measure the current in the base here. So what should you do? Disconnect this wire. And the current will be going from this point towards here. So the positive should be connected here to the midpoint of the voltage divider. And the negative to the base. Don't forget, you got to connect the circuit that you separated before, or you will get zero. And adjust it to amp, DC, and then turn on your circuit to measure the current at the base. Obviously, it's much less than the current in the collector. It's 3.5 microamp. The other one was like 3 digits, right? So that's how you measure the current in the base. So in general, when you measure the current anywhere in the circuit, you got to break the circuit and connect it by the digital multimeter. I think that's the important part that I want to explain. That's what you missed before. I hope that was helpful, and see you soon.